So if you've read the question, this is a question about survey design. Very exciting question, just very relevant anytime we're in a political season. A lot of polls come out. So it's kind of useful to understand a little bit the math that goes into designing these and answering some key questions about sample size. There's a lot of math here. I'm going to get to it in a moment. But let's just review the question. Pew wants to poll Arizona voters to see whether they like candidate A or candidate B more. And Pew has been given, which is very rare, but this is a hypothetical question. In this case, they've been given every email address and phone number of every adult registered to vote in Arizona. Usually that's something they don't have. So the first question they ask is to describe two sampling methods we can use to obtain an unbiased view of Arizona voters. Probably the easiest way is just to utilize the information they gave us. We have phone numbers and email addresses. We can go ahead and just randomly select phone numbers, call them, and ask, how do you feel about candidate A versus candidate B? This is probably we usually don't have a situation like this. I mean, if we did, and by the way, I would ignore the email addresses. I think data has shown that phones are a lot more reliable. We could use a few email addresses, throw that in as well. But this is a very unusual case that we'd have all the contact information. Usually what they're going to do is they're going to take all the area codes from Arizona, and these pollsters are then going to just start randomly dialing numbers. A lot of the numbers might not exist. That's fine. They have computers doing this, so it's not that inefficient. And then when somebody picks up, it gets connected to a person who can then conduct the survey. So what challenge may we face in trying to get an unbiased view? There's a lot of challenges, and one that might even be inherent with our kind of approach. What if candidate A voters like to pick up the phone and answer more than candidate B voters? All of a sudden, we might have a biased view, and we're just inherent in this process. And in that case, there would be nothing we could really do about it. I'd say we would just have to qualify the poll a little bit. And this is true, by the way, because sometimes this happens, and oftentimes this is a big reason why the polls are off in one direction or another. So the next question is, how many people would we need to survey to get a margin of error of plus or minus 5%? So there's actually a pretty simple equation for that, and that is the amount of people here that we need to survey. It's going to equal the z-score squared times the proportion times 1 minus the proportion divided by our margin of error squared. So what are these values? Well, z is essentially the confidence interval we want. So in this case, we want to be kind of 95% sure that. Sorry, we want. It's a little more. It's a little more complex than that. We want essentially we have a very high degree of certainty that the number we're calculating is indeed the true number here. The p hat is the proportion. So in this case, we would just make it 50%. Why, or 0.5? Why? Well, we don't want to. We're going to assume, and we're actually kind of forced to assume that candidate A and candidate B are roughly as preferred. Because if we have a fringe candidate, we would actually have to play around a little bit with that and maybe make P much lower, because that's really going to affect the results. But for a fairly even contest, we just make that 50%. The E that's our margin of error, in this case 0.05. And so we go ahead and we perform all these calculations. We're going to get 385. And that's consistent normally with what we normally find. Normally polls are going to want even less than a 5% margin of error. And that's why they usually have 400 to 500 minimum, sometimes over 1,000. Now let's say we're training an assistant. Well, I'm going to run out of time here. No, I'll have a little more time. So let's say we're training an assistant and they keep writing these bias questions. So for example, we see a question, and this would be a follow-up question perhaps about taxes. They may ask, how do you feel about raising the tax burden on taxpayers? Well, that would probably be a biased question because we load that negative valence there. We kind of only say, oh, okay, how do you feel about this bad thing? Because nobody likes to pay more taxes than they have to. So I would tell my assistant to say, look, we have to provide a balanced view. We have to take that negative and put the positive there too, because raising more money gives us opportunities to do things. So the question instead could be, how do you feel about raising the taxes on Arizona taxpayers in order to be able to fund important infrastructure projects or various services that residents may value? And then that would be a better question to ask because that gets the respondent thinking, okay, there's positives and negatives here, and now I really have to kind of look deep inside and ask myself, okay, how do I feel about this question? Great. So hopefully this was a useful explainer, and hopefully you all got something out of it. All right. Take care.